So good afternoon everybody, myself Acharya Vishwan. Today we shall discuss the concepts of velocity, speed and various questions based on them. So let's start with the questions, with the concepts. So let me define the term velocity. So there are certain things related to velocity. First is it's a vector quantity. It has magnitude, direction and added by laws of vector addition. Then its dimension is m1 l1 t minus 1, SI unit meter per second, CGS unit centimeter per second. 1 meter per second is equal to 100 centimeter per second, and 1 kilometer per hour is 5 by 18 meter per second, and 1 meter per second is equal to 18 by 5 kilometer per hour. These are of two types: average velocity and instantaneous velocity. Average velocity is displacement by time, which is vector s by vector t. Vector s is r2 minus r1 by delta t. In terms of coordinates for x-axis, we can write it as xf minus xi upon tf minus ti. For y-axis, it can be written as yf minus yi upon tf minus ti. Whereas for z-axis, it can be written as zf minus zi upon tf minus ti. Now there exists concept of instantaneous velocity, which is for x-axis defined as dx by dt, which is also equal to the slope of xt graph. For y-axis it is dy by dt and equivalently slope of yt graph. For z-axis it is dz by dt, which is slope of zt graph. Whereas in vector form it is written as dr by dt, that is first order derivative of position vector with respect to time. Then we have concept of speed. Speed is a scalar quantity, has magnitude only. Its dimension is also m0 l1 t minus 1, SI unit meter per second, CGS centimeter per second. 1 meter per second is equal to 100 centimeter per second. 1 kilometer per hour is 5 by 18 meter per second, and 1 meter per second is 18 by 5 kilometer per hour. These are the same things. Speed also are of two types: average and instantaneous. Average speed is total distance by total time, where instantaneous speed is magnitude of instantaneous velocity. So that is the point of concern over here. Now let's move our attention to the term acceleration. So regarding acceleration, it's a vector quantity. It has magnitude, direction and added by vector laws. Dimension of acceleration is m0 l1 t minus 2, SI unit meter per second square, CGS unit centimeter per second square. It is also of two types: average acceleration and instantaneous acceleration. Average acceleration is delta v by delta t in vector form, and in coordinate form d and delta v by delta t. Instantaneous acceleration is dv by dt. In terms of vector, you differentiate vector, and in terms of coordinate, you differentiate the velocity when it is given as a linear function. And also, it is the slope of velocity time graph. That is how you can find acceleration graphically. Now let us study something related to the graphs. So the first thing is xt graph and position time graph. So suppose a particle is moving along x-axis such that xt graph is shown in the figure. So at a certain point P, if you draw a tangent, and suppose the tangent makes an angle theta with the t-axis, then we define velocity as tan theta or dx by dt, which is definition of instantaneous velocity, which is also the slope of xt graph or the slope of position time graph. Now there are some different cases. If theta is less than 90 degree, then tan theta will be positive. That means velocity will be positive as given in this graph. If theta is 0 or 180, tan theta will be 0, so velocity will be 0 as given in this graph. If theta is greater than 90, then tan theta will be negative, so velocity will be negative as given in this graph. If theta is 90, then graph will be having infinite slope, which corresponds to infinite velocity, which is maximum possible permissible velocity. Now let us analyze Vt graph. Suppose a particle is moving, velocity time is as shown. This is point P. This is a tangent to the graph, and this makes an angle theta. So acceleration is dv by dt, which is tan theta, which is slope of velocity time graph. Same cases, if theta is greater than 90, so tan theta will be negative. That means acceleration will be negative. So if we have a velocity time graph like this and tangent makes obtuse angle, then its acceleration is negative. Whereas if theta is 0 or 180 as shown in this graph, then acceleration will be 0. However, if theta is 90, then tan theta will be positive, then acceleration will be positive. However, if theta is 90, then tan theta will tend to infinite, or acceleration will tend to infinite. Next, we have a question based on this. Xt graph is given, and the first question is x is positive for. So you can see that there are certain points A, B, C, D, E, F. So x is positive for A, B, C, negative for D, E, F, 0 for these points, O, M, G. Velocity is positive. So velocity is positive and slope is positive, and it is positive at A, F, and G. Similarly, velocity is negative where slope is negative. That is where tangent make obtuse angle with D axis. So these are possible at C, H, and D. Then another question is velocity is 0. So velocity is 0 when tangent is parallel to T axis, which is possible at B and D. Then we have acceleration is positive. So acceleration is positive for concave up shape of graphs, so which are possible at D, E, F. Whereas acceleration is negative for concave down shape of graph, which is possible for ABC. And it is 0 at the point where these things intersect, which are possible at AH and OH and G. So these were certain questions based on that. Let us solve some other questions. So here the first question is y is given here, and we need to find dy by dx at x is equals to 1. So you can differentiate it. So dy by dx will be 3x square minus 6x plus 2 if x is 1. So this is 3 minus 6 plus 2, which is minus 3 plus 2, which is minus 1. So third will be correct. Next is velocity is this. Instantaneous acceleration at t is equal to 2. So you just differentiate acceleration, which is dv by dt, and it will be 4t. So t is 2, so 4t will be 8. So acceleration, sorry, 40, t is 2 seconds, so it will be 8. So just do that option as 8 meter per second square. Next is inner round trip displacement is, so it is 0. Next, roots of the equation x square minus 7x plus 12. So this is a quadratic equation. You can find the roots as 4 and 3. Next is what is frame of reference, what are inertial, non-inertial. So frame of reference is basically the observer. These are of two types, inertial and non-inertial. For inertial frames, acceleration is 0. Non-inertial frames, acceleration is non-zero. Then another question is what is velocity, what is SI unit, types of velocity. So velocity is a vector quantity, SI unit is meter per second, types are average and instantaneous. Next, derive equation graphically, you can draw using the graph. Then we have another question, xy coordinates are given, velocities are given. So velocity along x-axis you just differentiate it, dx by dt. Along y-axis you find dy by dt. What is the speed? So speed can be found as root under vx square plus vy square. Then what is displacement, what is distance, differences between them. Again, theoretical question, you can easily solve that. Then we have another question based on derivation of the equation. These can be derived using integration. Then we have a question based on motion under gravity. So this can be easily solved using equations of motion. So in this way you can solve the questions. So these are basically concerned with velocity, speed, acceleration, and the problems based on them for your school exams as well as for competitive exams. So we have tried the best to put you the best of optimized information source. I hope it will prove to be a boon to you in your exam preparation. Thank you and have a nice day.